Thank you for your interest in the user interface software for the InSync adaptive traffic control solution from Rhythm Engineering. The user interface software is provided to each of our deployment partners free of charge, without ongoing licensing fees or limitations on the number of users. The user interface software is designed to allow our local deployment partners direct access to the InSync processor located in each traffic cabinet. By doing so, the local traffic professionals can view corridor conditions, input their preferences and parameters for InSync's operations, as well as receive information from InSync on both historical traffic conditions and operations, as well as alarms. The first of the two user interface softwares is CentralSync. CentralSync is a Windows-based application that allows the traffic professional to create configurations for their corridors, input and update those preferences, and manage alarms. The second software is the Web UI. This is a browser-based software application that allows the local deployment partner to view live camera views of their corridor, adjust those cameras, see historical information, and directly access each processor in the cabinet. We'll first take a tour of the Web UI software. In the Web UI, we can see live camera views of actual traffic conditions on the corridor. We also see things such as the light status and textual information on what the InSync processor is seeing and receiving, as well as what it plans to do next. There are various camera views to choose from, whether we look at a single camera, all the cameras at an intersection, or we can actually view the entire corridor on one screen. Now, let's take a look at the statistics page in the Web UI. In the statistics page, we can enter a date range, identify a time range. Here we'll take a look at the AM peak for this week. And we can choose what type of data we would like InSync to show us, whether it be counts, delay, or level of service. Here we'll leave it at vehicle counts. We can see the information in a table format, or download it in a text format, or view it as a graph. Here we'll pull up the graphical view . Now let's switch over to the history viewer screen to get precise phasing and intersection information for a particular day and time of day. Let's choose the AM peak again, and let's look at specifically the time between 8 a.m. and 9 a.m. And let's also tell the system to highlight any wait times on any of the phases over 75 seconds. We can download it, the data, in a CSV format, or generate the report here in the history viewer. Here we see exactly what was going on at the intersection by time of day, the duration of the movement served, and what else was going on at the intersection at that time as far as the queue and the wait times. We can also see the coordinated movement being served, as well as any adaptive functionality applied to that coordinated movement. We can see things such as pedestrian calls, and we could also see any EVP preemptions going on at the corridor. We're looking for wait times exceeding 75 seconds, and here we see a couple. We can also tell the reason for that wait time exceeding, in this case, most likely due to the pedestrian service. Now let's take a look at the second user interface software for InSync, CentralSync. We're going to start by setting up a new corridor. We give that corridor a name, something that will be convenient and familiar to you. Then we establish the first intersection's location, and Google Maps is going to help us out by finding that intersection. Then we enter basic IP address information, as well as the phasing available for that intersection. Once we input each intersection on the corridor, we then draw what we call tunnels, which indicate the coordinated movement from one intersection to the next. We add these tunnels so that InSync understands the origin and destination of the coordinated movements. We draw these tunnels in each direction. Typically this work is performed by Rhythm Engineering staff prior to deployment, but of course we make this functionality available to all of our deployment partners. Now that we've input our coordinated movements into Central Sync, we set up our preferences for each individual intersection. We signify the permitted phasing for each intersection, just as simple as a click of a mouse. We input our preferences for the sequencing. We can lead or lag our left turns, or both. We input the minimum light times that are programmed into our controllers so that Central Sync and InSync have awareness of those. And we can input pedestrian phase information. We can add a new pedestrian phase, give it a name, input the walk and don't walk times, and associate it with a permissible vehicle phase. Now that we've entered our preferences for each individual intersection, we'll work on the progression protocols. We can adjust the amount of green time dedicated to the coordinated movement at each individual intersection, which of course allows more green time for the side streets. We can also edit the thresholds on the tunnel truncation, which is one of the adaptive components of InSync. It allows a coordinated movement tunnel to end sooner if there's low demand. And we can adjust the dynamic period, another one of the adaptive components of InSync. It adjusts the amount of time between serving the tunnels or the coordinated movements. We've seen how easy it is to set up recurring configurations, but we can also schedule special configurations. So for instance, if there's an event happening on or near the corridor. Here we see a unique configuration because perhaps there's a special event happening on the northwest corner of these intersecting arterials. We can set up this configuration and schedule it to be implemented at some point in the future. Finally, in Central Sync, you can set up alarms that can be delivered by both email or text message. Here we'll set up a new user, input his name, add his email address, choose which types of notifications this person should receive, and on what days the user should receive those emails. And it's that easy to add and change alarms using Central Sync. Thank you again for your interest in InSync and its user interface software. For more information on the hardware components of InSync, the adaptive algorithms and models that drive InSync, and the particular benefits of installing and deploying InSync in your community, please visit rhythmtraffic.com.